Hello and welcome to the worldwide sport of welding. I'm your commentator for the evening. Alright, hello and welcome guys. This is a new module, so we're starting out fresh. Alright, I want you to make sure that you subscribe to the YouTube channel so you can see all the lectures or go back if you need to review. As always, if I go over something too quickly or you just don't get it, please ask questions. Please post it in our classroom so everybody can get the information, okay? I don't want you guys to wait till the very end when you're really confused. Everybody's really busy, and you might not pass, okay? All right, so today we're going to talk about GTAW, or gas tungsten arc welding. You probably heard a ton of different names for it. TIG, tungsten inert gas, or even an old term, heliarc. That's when they were using helium in an arc welding. Okay, so here we go. All right, so we're going to talk about the equipment first and the basic principles today. So let's start at the very beginning. Okay, so we know that we use a gas as a protective shield for the weld. We generally use 100% argon. We'll go into that a little bit later, okay? So into that, we also use a non-consumable electrode. Well, let's define electrode. Well, it carries the electricity, okay? So what is non-consumable? Non-consumable is non or not consumable or consumed or used. So this would be our tungsten. It carries the electricity, but we're not using it as a filler metal. We use a separate filler metal, and you need a torch and we need a ground, okay? So we also need, for TIG, a constant current welding power source, okay? We need to be able to keep the amperage the same throughout our welding. In CC, our autocorrect is trying to make sure that the amperage stay the same and varies the volts. So we keep a constant arc length is essential when we're talking about TIG. Okay. Now, we also use what is called high frequency. Okay. High frequency is used for a couple of different things. High frequency allows us to start the arc without touching the tungsten to the workpiece and possibly contaminating to start it. And the other thing is, in order for us to keep the arc going when we run an AC. So, let me skip to a picture here. All right, so I want you guys to notice this. So when we run AC, we have a positive and a negative. But I also want you to note this arrow or this line right here. And it says 0. So in one cycle, it goes from positive back to negative back to 0. So that means at 2 times during our cycle, the arc is at 0. So if we didn't have high frequency, we would lose our arc when it would go to 0. So that's really important. That's the science behind things, okay, guys? All right, let's go back. Let's keep on going. All right, so we're back to our chart. This chart, it shows that you might want to use particular base metals in accordance with particular currents and polarities, okay? So the most common is mild steel, and we're going to use DC electrode negative. If we want to run aluminum or magnesium, we want to use AC. Now, this chart gives us a 1 and a 2. So it says 1, excellent operation, best recommended, or a 2, good operation, second recommendation, or NR, not recommended. So we can use AC for some of these things, but not recommended for others. Okay. Alrighty. So we also want to remember, if we look at this chart, this is not a never ever chart. Okay. We need to remember that there's not one process that does it all. Not one rod or electrode will do it all. And the same goes for polarity. Okay. There's a time and place for everything. So I had worked with a company, and I still work with them, that does work for SpaceX. Okay. And they TIG weld on aluminum. And they run aluminum on DC electrode negative. And they use helium for the gas. So things are never ever set in stone. We're working with generalities right now. And there might be something special that you come up against that you have to kind of bend the rules and change things. And we're learning. Okay. All right. So now we're going to talk about polarity. Just a quick review. We know that DC electrode negative is also called DC straight polarity, which means the electricity goes straight into our workpiece. When we talk about DC electrode positive or DC reverse polarity, we know that the electricity goes from our workpiece up, okay? So when we use TIG, we generally use DC electrode negative for ferrous materials. If we use DCEP, you'd have to use a lot of current, and the tungsten itself would have to be extremely large to be able to carry those amperages. Okay? So we tend not to use it. What's really cool is polarity. We know polarity affects the shape of our weld and how much penetration we're getting. Okay? So DC electrode negative has 70% of the heat directed towards our weld. Okay? And we also can see that DCEP has a really shallow, wide pattern, and 70% of the heat is going away from it. Okay, so in AC, it's just about a little bit in the middle. Okay, so let's talk about AC. AC is in a league of its own and is a lot to talk about. Okay, so in the beginning, way back in the day, what they had was conventional sine wave. Okay, and this was made from a transformer rectifier. It would create waveforms 60 cycles per second, or 60 hertz as a sine wave. Okay, this wave is not the best because it doesn't stay in one waveform, positive or a negative, long enough to clean well enough or penetrate well enough. Okay, but this wave is considered a balanced wave because the positive and negative cycles are balanced. Okay, so we need to know that the electrode, or I should say electrode positive is the cleaning portion. Electrode negative is the penetration. Okay, so here comes technology that changes everything. Next thing up, well, square wave. Well, you guessed it, it makes square waves. Ha ha ha. Okay, so this waveform can be changed. Now we can change the amount of time. Okay, so square wave allows us to change the time. How much time do I want it to clean, or how much time do I want it to penetrate in my wave? Okay, so we can adjust it to 30% cleaning, 70% penetration, or however you see fit, depending on the material that you have and the type of penetration that you need, or if it's really dirty material. Now, here comes the inverter. Okay, inverters are newer technology, probably within the last 10 or 15 years. Okay, inverters allow for our machines to get super small. Okay, currently Miller has a machine for TIG. It's like the size of a small lunchbox, like the one that you took for school, that little metal one. Yeah, it's that big. Okay, doesn't mean it has the most power, but it makes it extremely portable. Okay, so this inverter makes a true square wave, and it has really fine controls. Okay, I can go from 1% cleaning to 99%. Okay, pretty cool, right? So we're also able to use a smaller tungsten. Okay, and sometimes in certain procedures, there's a maximum cleaning time that I can have, and so I can have a correct penetration in the weld. Okay, usually this is going to happen when we have contract for aerospace or really mission critical parts. Okay, so inverters can output between 20 and 200 hertz. Okay, yes, it hurts. Okay, so the lower the frequency, the softer the arc. It will have a really wide cleaning zone, a wide bead, and really shallow penetration. Okay, now look at the difference. We can make this really a long time, or we can make this really a short time, depending on what we're trying to do. So if we look at 60 hertz and below, we can reduce porosity when we have like oil-soaked aluminum or something that's extremely dirty when we're trying to make repairs. And if we go above 60 hertz, the arc is more narrow and focused, and we can make really small, thin welds on really thin material. Okay. We also need to remember that amplitude. What is amplitude? Let's see if I have it here. Amplitude is the height. Okay. Amplitude helps us. It's called the amplitude control. It allows to change the height of the positive and negative. So now not only can we affect the time, we can affect the amplitude. What's amplitude? How much, right? Okay, really pretty cool. Okay, so this can change the way we direct heat, especially into our materials. And okay, so we know that what? Electrode positive cleans, right? And electrode negative is penetration. So if I give it more negative, I'm going to have more penetration. Or if I'm running, thinner material, I might need less penetration because I don't want to burn through the material. Okay. It's really kind of cool because you guys get to change this. It's so okay. All right. So let's talk about machines. We're gonna need a machine. What's our machine? Okay. So of course we need a welding machine. We need to make sure it is capable of CC power. Nowadays machines have CC, CV, or some of them have both. Okay. You can have, if you have an air-cooled torch, you're going to not need a water circulator or an inverter. But if you have a water-cooled torch, you're going to need an intercooler or a radiator. You're going to need a remote. This is your current control. It's either a foot pedal or a finger switch or things like that. We're going to need a regulator and a flowmeter. Now, why would I need a regulator and a flowmeter? Remember, machine doesn't regulate the flow of gas. All it does is turn the gas on and off at the appropriate time. So that means we need to be able to tell it with this little flow meter, not the regulator, but the flow meter, how much gas should be going into my machine at the time. Okay. Of course, we always need gas. All right, so generally, 95% of the time, don't quote me here, we're going to use 100% argon for TIG. Okay, there's other things that we can use, but let's just keep it there. Okay. So I'm going to call it quits right now, and we're going to do a part 2. Talk to you later. Take care. Ta.